Same sample derived from the any population. Any population is repeated in treatments. Repeated in treatments of same factor. Of same factors. Of same factors. Same factor के लिए repeat करना. The sample derived from the any population is repeated for the treatment of same factors. इसीलिए इसको बोला गया single factor repeated measure ANOVA. And here the three essential features are necessary. And if you debar any of the essential features from the during the experiment, then it will give the उसको बोलते हैं noise effect. अभी हम समझा रहे हैं what is noise effect. Here first randomness. Three essential features for the three essential features for the research designing is the randomness. Second, covariance. Randomness, covariance, and third, population deviation. Population deviation means randomness, covariance, and population deviation. That means here, if you collected this one, then the null hypothesis represented in the form of the factors. At first you study the factors. The factors is the total variability. Total variability, between variability, within variability, between variability, within variability. Here the between variability is caused by first कौन सा treatment effect, population होगा कहाँ से, treatment effect. Second, experimental error. Experimental error. And here within variability is the experimental error. And second one is the variability within subject. Variability within subject. That means here the within variability is experimental error and between subject. Between subjects. That means if you constitute the F form, there are two factors, treatment effect, treatment effect plus experimental error divided by experimental error. ठीक है, treatment effect divided by experimental error. That means here MS between divided by MS era. MS between divided by MS era. That one factor is here. Again, that means during the calculation of the AF statistics, it is necessary to calculate the MS error. MS between is same. MS between is same. And in notation, all the notations are same as used in the single factor independent measure except PS. PS, that is the personal total. That is the personal total. J1 to K. Sorry, personal total equal to J1 to K xi. It represents the personal total. It is the difference. It is the difference. Only one notation. All notations are same as we observe in the independent measure, single factor and independent measure ANOVA. Clear? Hypothesis क्या बोल रहा है? कि mu 0 before treatment equivalent to the is equal to the mu 1 after a gap or equal to the mu 2 after a gap. That means there is no effect of the exposure time. No effect of the exposure time, but the alternate hypothesis represents that the exposure, the mean value of the time gap treatment is effective. Clear? And here the total variability here is divided into between variability and within variability. Again, the within variability in the repeated measure ANOVA is divided into between subjects and experimental period. In the total variability, for the calculation of the total variability, we calculate the sum squares of the total by the formula total of the x square minus x square of the total samples divided by n, and then we calculate the within variability SS, the sum total within, by the mean deviation of the all the scores of the sample from I to J treatments, and then we calculate the between variability by subtraction of the SST minus SSW. Here, these components are as same as independent single factor independent measure, but when we again differentiated, like to differentiate the within variability, then the within variability is further divided into between subjects and experimental period. For the between subjects, we use a new notation, that is the PS, personal sum, and the personal sum represented the value summation of the xi from J1 treatment to K series, K treatment group, J1 to K, and here this one is the P1, this one is the P2, this one is the P3, and this one is the Pn, where we consider the treatment group after some time from 1 to 2, from 2 to 3, like this. And in this condition, the square of the personal summation, total square of the personal summation is divided by K and minus the total sum square, total x square value, total x square value divided by the n. It represents the between subject sum square, and thereafter we calculated the experimental error, sum square of the experimental error, by subtracting the within between subject SS between subjects from the SS within variability. And in these conditions, after the calculation of the sum squares, we calculated the sum squares of the different factors, and now we calculate, thereafter we calculate the degree of freedom. Then the degree of freedom of the total is n minus 1, that is capital N minus 1 total. And that is degree of freedom between is k minus 1, degree of within, that is n minus k, degree of freedom between subjects, a small n minus 1, degree of freedom of error, that is n capital N minus k minus a small n minus 1. And after the calculation of the sum squares and degree of freedom, we calculate the variance of each component. Of course, I am asking and saying again that the variance is represented in the form of MS, in the F test MS. Then we calculate the MS or the variance of each component by dividing the sum total by the respective degree of freedom. And thereafter, we calculated the MS between SSB divided by degree of freedom B. Then we calculate MSE SSE divided by degree of freedom E. And then we calculate the F by the MS between and MS divided by the MS error. टेबल में रिप्रेजेंट करना है, जैसे उसमें बदला था ना एनोवा टेबल, यहाँ भी लास्ट में कितने कंपोनेंट आ गए आपके पास? एस आया, एस, ठीक है। दूसरा कौन है? डीएफ आया, उसके बाद एमएस आया, एमएस आया कि नहीं आया? एफ आया, ठीक है। एसएस किसका आया? between within between subject error total. Here SS, BF, MS, F. SS between, अब ये सारे वैल्यू को आपको यहाँ पे लिखना पड़ेगा, and then you represent all the calculated values in the table, and here यहाँ पे लिखिएगा एनोवा टेबल, एनोवा टेबल, ठीक है। या इसको पूरा लिखना चाहिए तो आप लिख सकते हैं सिंगल फैक्टर रिपीटेड मेजर एनोवा टेबल, पूरा लिखिए। सिंगल factor repeated major ANOVA table, ठीक है। देन यहाँ पे क्या है, दो चीज हमेशा ध्यान रखिएगा फिर कि ईयर यहां तक जो आप रिप्रेजेंट कर रहे हैं तो एसएस सभी का लिखना होगा। कहने का मतलब व्हाट इज द वैल्यू ऑफ एस एस बी यहाँ पे लिखिए, व्हाट इज द वैल्यू ऑफ एस एस डब्ल्यू यहाँ पे लिखिए, व्हाट इज द वैल्यू ऑफ एस एस बिटवीन सब्जेक्ट यहाँ पे लिखिए, एस एस ई यहाँ पर लिखिए, एस एस टी यहाँ पर, डीएफ का वैल्यू यहाँ पे लिखिए सबका। डीएफ लिखने के बाद एमएस वैल्यू लिखिए, ठीक है। एमएस वैल्यू के बाद क्या लिखना है, एफ। एफ में दोनों वैल्यू लिखना है, एमएस तक तो आपको सभी का वैल्यू लिखना होगा। कहने का मतलब यहाँ पर आपको एमएस बी भी लिखना है, इन्हें की दो लिख के कैलकुलेट करके छोड़ दीजिएगा। एमएस डब्ल्यू भी लिखना है, एमएस बीएस भी लिखना है, एमएस ई भी लिखना है और एमएस टी भी लिखना है, ठीक है। और जब आप एफ पे आएंगे तो एफ पे आपको केवल लिखना है एमएस बी एमएस डब्ल्यू ई ई, जो वैल्यू आएगा वो यहां पे लिखें। एंड दैट इज अगेन रिप्रेजेंटेड हियर क्रिटिकल वैल्यू, critical value that is AF 0.05 DF of किसका, between DF of between DF of E, DF of E, यहाँ पे W नहीं, यहाँ पे E, that you analyze the rejection or acceptance of the null hypothesis. Clear?